Hey everyone, welcome from wherever you're joining us, whether YouTube or LinkedIn. Welcome to this week's webinar from Integrated Projects. Very excited to have you. So today's a very special one. We're going to be talking about something really, really important and near and dear to our hearts. And it's a topic that I think many that work within the industry that are looking for things like accuracy will resonate with. So the talk today is called Get Control of Control Points. And yeah, should be fun. So we're just going to do a quick intro to ourselves, provide some background as to like what control points are, why it matters, highlight some of the risks that are part of not using things like control points when you're surveying, and then also how to work with us. So, and I think we'll also reserve some time for comments, right? So if you have any questions or comments you want to drop in wherever you're watching us from, whether YouTube or LinkedIn, feel free to do so, and we'll pick them up towards the end. We'll try to get through this with it, and have some like 15 minutes at the end to discuss. So I'm George, head of product here at Integrated Projects. My background is trained as an architect and landscape architect. But I've spent most of my career working in tech, looking at ways to bring innovative technologies to the industry and to radically rethink workflows. And I'm joined by my favorite co-host, Tyler.
Awesome. Thanks, George. Yeah, my name is Tyler Putnam. I'm head of solutions here at Integrated Projects. And just like George, my entire career really is focused on the intersection of, architecture, the built environment, and technology. So I'm registered here in New York, and historically been doing, lots of technology consulting for companies like Symmetry, large corporate architecture firms like SOM, Ramza, KPF, so on and so forth. And I'm super excited to present this topic. It's not a little bit of a dry topic, but we're going to try to spice it up for you. But it's super important nonetheless.
Don't worry, we'll make it spicy. So just to reset on sort of why we're here, why does integrated projects exist in general? Essentially, it's because there's not a lot of validated information out there related to buildings. So anyone that works in and around buildings would be familiar with something like this, whether it's a rolled up blueprint, a series of blueprints, or an outdated PDF that lives somewhere on Google Drive. The reality is that a lot of people are working with unverified information in out-of-date plans, and it has issues, right? It's a lot of basically the consequences of not having accurate data can compound throughout the course of a new renovation or some other design and construction project. So we believe that there's a huge opportunity to be the future of how companies verify spaces. And we believe so much in it that we do it end to end. So we have two different services: Scan It, which means that you can mobilize us on site, almost like requesting an Uber. You basically give us an address through our platform, and with a couple of details, we can get started on the process to go on site within a matter of days, and then scan a space and use the next service that we have called BIM to digitize it. So we take a point cloud, we bring it into Revit, and we start to basically go through the whole process of QA/QCing. Along the way, we leverage um, our platform to deliver everything. So it's a very simple process. Basically, depending on where you enter from, it could be two to three steps. And we also have simplified the way we can do this is by simplifying the scope of work. So unlike maybe some other more traditional ways of doing this, you might have a lot of ambiguity in terms of what's the scope that you want to actually convert into a digitized model. We make it very, very easy for folks, which means that, as we've talked about in the past, we've had to really focus a lot on operations and how do we systematically improve that. And as I mentioned before, we deliver it all into a very easy to use viewer that allows you to do a lot of different things like cut sections, take screenshots, add comments, get even quantified counts of all the elements that are inside the deliverable that we provide. We also host virtual tours for free for our customers, whether it's things that we've created or ones that you want to host, to help people collaborate more effectively around that kind of pre-construction stage. We've also done this a lot, over about 5,000 times, in a very short amount of time. And so we've learned a lot about what it takes to deliver this at scale and at quality, um, to the point where we've been able to do it also across a whole series of project types, from very small spaces to large complexes, whether industrial or airports or pretty big, massive square footage. And along the way, we've also, as you probably have heard, we've started to use this really fascinating, what we believe to be the largest structured data set of buildings in the world, to unlock new, let's say, basically moving towards a foundational model for scan to BIM conversion. And we have made incredible progress. We're about to, in let's say a month or so, announce some pretty exciting updates to this. But essentially, we are able to segment point clouds, convert them into Revit models, and use that into our own processes, saving our own modeling teams significant amount of time. So today we're going to talk about control points. Control points. We'll get into more detail about what they are, but I think it's helpful to kind of work backwards from what happens when you don't use something like control points. Essentially, control points help to uh, align the scans that are produced in the field in a way that they can be registered and provide a cohesive, integrated space. And so you'll see images like this, like a point cloud, like the digitized version of a space, and you'll see examples of people wearing gear to be able to capture that space. But a critical component is being able to then match these different points that are collected in various software so that they accurately represent the real world. And this problem compounds about alignment compounds when you're talking about large spaces, where if you can imagine that these are very sophisticated cameras with a lot of sensors, but over a long enough space, they can start to kind of lose track of where things are. And so all the control points do is help to make sure that there's a checkpoint in some sense, so that the people, there's a good reference point. So large spaces can come into conflict here. Things like stairways, like if you're scanning multiple different floors, there can be a lot of issues there if we're not using these type of markers in space. And then also even things like hallways. If you've ever been to Las Vegas and stayed at a hotel there, you probably have come across, I think it's the Venetian that has like those long kind of like spooky infinite hallways that are very undifferentiated. That's not good, right? Because if you're thinking about like these sensors with cameras, right, if it sees the same thing many times, it kind of like loses the plot. It's like, wait a minute, where am I now? And which is actually not unlike walking through the Bellagio after heavy dinner and drinks. And with that, I'll pass it off to Tyler to tell us what's the point of all this, Tyler.
Yeah. So what's the point? The point is that control points are super crucial for large scale complex projects, and you really need to be able to know when to use them, how to use them, how to specify them, what the potential cost or schedule impact is going to be. And there's I've been working in architecture for the longest time in my career. I always heard about survey and control points and all this stuff, but I didn't really have a good visual of really what's happening behind the scenes. So I think what we're trying to get after here is to just sort of demystify, what's a project control, what's a control point, what's a target, what's a survey point, all of those things. And and we're going to keep this kind of high level, but also hardware agnostic. So we certainly have our preferred, scanning devices and partners, but really at the end of the day, we're dealing with very sophisticated technology that's been built on, tremendous work of mathematics and computation and all this stuff, and it seems like it's magic, and in many ways we kind of make it seem like it's magic, but at the end of the day, it's really laser beams, right? So a couple of things that can happen. There's probably we have a QAQC checklist on just our scanning process alone that I think has like 12 points of failure that we look for. But there's two in particular, which by and large in our experience are the ones that cause the biggest issues on projects, right? And the first of which is bad bad data that won't allow you to align point clouds. So here on the left, you've got one point cloud scan, which is represented in blue, another that's represented in red, and those somehow need to be able to come together and be stitched together. And we're talking hundreds of millions of points, if not more, to bring those together. And when our goal, right, is construction grade 5 to 15 millimeter accuracy, you could understand or start to appreciate just sort of the level of insanity that this task really is, right? So on the right, this is something that we have found when we're scanning these larger spaces. If we don't set the proper control points, which there is a cost associated to it, there is schedule impact, et cetera, which we'll get into. You can see that there's a delta of 4 inches of these two different walls. So the red and green walls that are overlapping here. This as any BIM modeler knows, you can't rely upon this information to produce the model. So downstream of this, right, we can only be as accurate. Everything that we're doing in architecture, before we're actually building the project is some, by definition, some degree of abstraction. So when we're scanning a space, when we're gathering the existing conditions, reality capture, we have one level of accuracy, sort of representation of the world. And then when we model it, we have one, sort of further downstream, right? And then that's where we get you started off the 50-yard line as a designer, as a construction manager, as an owner operator, and then you take it downstream from there. So starting off and getting correct, accurate data is super crucial for the project. And the second problem that we often have seen when we don't use survey control points or target points is scan drift. And this is really very specifically for a type of LiDAR scanning technology called SLAM, which we'll get into in a minute. But just note that it it has there's a tendency, right? If you cannot register the millions of points that you have, your position in the space, the velocity that you're moving through the space, and be able to rectify all of those, there can be all kinds of different distortions, whether that's like a translation, a rotation, um, all kinds of different distortions that can crop up. And so really the reason why we are doing this whole webinar here is to just raise general awareness about survey controls, not to say you need to know everything about them so that you can do it, but really what they are, some basic terminology so that you know when you need them, how to use them, what kind of impact that's going to have on your project. So I'll kind of back up from there, right? What's a survey point and what's a control point? At the kind of foundational level, every city and every state across the world, generally speaking, have established benchmark monuments that are survey points. So here on the left, you can see there's a number of these points. These are either coordinated or updated and managed by the state or the city. In some cases, it could be even a county, et cetera, et cetera. But they, at least in the US, are known as primary control points, and they are registered with the National Spatial Reference System. Effectively, more or less, there's two different coordinate systems that it has to has to be compliable with, right? That's the North American datum of 1983, typically known as NAD 83, and then vertically the 1998 NABD for the vertical orthometric height. These are already established, by local or federal governments, right? And these positions are the ground truth of geospatial positioning. So downstream from that, on more of the local level, you get your second, your third order, your fourth order control points. These are where a licensed surveyor will basically geo-reference using trigonometry and lots of technology, all kinds of things, to very specifically get the northeast coordinates, the grid coordinates, the spot elevations, even crazy, convergence angles, right? As you can imagine, the world is a sphere, so doing math on a sphere, even made us break Euclidean mathematics, right? And invent an entire new way to do this type of computation. Downstream from that, so generally speaking, the second orders will be, let's say on street intersections or major structural grid lines, and then the basic parameter. Then you can start to triangulate your way into your third order control points, et cetera, et cetera. All of these are tying back to those primary control points to be able to give us a geolocated reference to where we are in the world in, let's say, 5 to 15 millimeter accuracy. When you start to get into this stuff, it's a little bit crazy. And we're not going to go into a deep rabbit hole here, I promise. Although I can at any point if anybody wants me to. By the way, please feel free to leave any questions or comments, in the chat. We're always looking for, we do this webinar series every 2 weeks. We're always looking for, what's the best value, what's the topics that you want us to cover, different things like that. So generally speaking, how are these control points actually established? You're typically going to use what's known as a total station, which you can see here on the right, or a GNSS receiver. These have to be performed by a licensed surveyor, and they have to be tied to a geographic coordinate system, like latitude, longitude, universal transverse Mercator, state plane coordinate system, et cetera, et cetera. There's a bunch of mathematics that will translate from one coordinate system to another. So if you end up, your civil or survey engineer gives you coordinates for your Revit project in, the wrong way, you can actually translate them between. But effectively, they use these total station GNS receivers, and they use trigonometry with the verified points to derive at yet another point downstream from there, as many times as you need, depending upon the project requirements. And ultimately, as an architect, engineer, general contractor, this is usually where we get our first kind of exposure to this kind of documentation. A little hard to see here, but what you'll see on civil survey drawings are, X's and triangles, right on the civil plan with a number on it. That number corresponds to Excel spreadsheet, some kind of tabular data that contains the northern and eastern coordinates as well as that height, right? If you have survey points or control points or target points or any point for that matter that doesn't have north, east, and height into it, it's actually not a control point. They can still be useful, but it's not technically or legally speaking a control point. So why does this matter for architects and engineers? Well, when you get into Revit, now, many of you may not have even looked at this before. Many of you have probably if you have looked at this, know how troubling and difficult the management of the survey point, the project base point, or multiple project base points, and the internal origin can be. But in order to accurately georeference your project, your survey base point needs, as you can see here, the north, east, and elevation. And you can simply input the data there, and it will geolocate exactly, mathematically speaking, your project onto the Earth. Without that, it's just kind of guesswork, right? The project base point, on the other hand, is a local coordinate system, which is sort of tied only to that project. That can also be tied to a control point. Doesn't have to. There can be multiple project base points in a project. I was consulting on, I'm thinking some of these crazy international projects where we're doing 30 buildings in a community, high rises, all of this stuff. I think we had something like 100 different project base points in that, right? And then finally there's this sort of invisible, unspoken, really difficult to pin down coordinate system that's relative only to Revit, which is called the internal origin. And that's simply used for coordination between other file software like AutoCAD or Rhino or these various different things, right? By the way, if you want me to do a webinar or a guide, a deep dive on survey points and project base points, just let me know in the comments. I've got a real deep dive on that, technically speaking. For
Tyler,
those of
actually,
you, yeah,
before you continue, I'm curious. Like, I think it's important to note that while we're talking about this through the lens of existing conditions, in some sense, for um, let's say renovations, interior and exterior work, etc. I mean, you just brought up like even whole new buildings, right? Like whole new communities. Like the impact of this technique, technology, associated technologies, etc. Like actually has a lot of implications, not just at the scale of something small, but also massively for things that are much larger as well. So it's almost like a, one can think of it as a default thing to do almost when you're talking about a certain size of project.
Yeah, absolutely. I mean, there's nothing more foundational than the survey, right? Interesting. Like when I went to architecture school, literally the first week we did an investigation of the philosophy of the survey, right? And it's the lance that that stakes the ground, that becomes the axis mundi, which is the center of the world, becomes the axis of the transverse and the nave of the church, right? I mean, it is so foundational, and yet kind of a mystery for most of us, right? Sorry, not to wax poetic on that.
No, I mean, I was about to, I was about to jump into the territory we talked about
Yeah,
before this, about just like how, yeah, like how even things like earthquakes actually change the world and therefore change delineation of property because of this stuff. But that's more for
absolutely.
another time. Maybe in Vegas someday.
Yeah, maybe for that long corridor in Vegas. Okay, but so let's get back on track and get in control. So, what are control points? These are the typical ones that you're going to see out there. So, at the very basic level, you have a quadrant marker, which literally is a black and white checker box that is used for general visual interest. And this can be tied into controls or not, meaning it can be tied back to the geolocation or not. And in the case that it's not, it's really just a marker or a target. Now, this is still very useful, as we'll get into in just a minute, but just know that when you're using this kind of target, it's not geolocated. The same is pretty much true with, oh, awesome. Scott. Yeah. It's great to see Scott here, actually, a lot of our conversation that Scott and I recently had kind of inspired a lot of this speech here. But yeah, I'll definitely do a deep dive on Revit coordinates. In addition, you have April tags, checkboard targets, right? Spray paint mark. All of these are sort of the same. They're for visual alignment. They're for photogrammetry, which we're not really going to talk about today. They're also for overlap detection. But the point is that these can be set up without geolocation targets. Um, and then you have field labeled manual control points, which could be spray painted, they could be marked, they could be, oftentimes just like a scratch on the floor. And when those are provided with a tabular set of, notated georeference, then they can actually tie back into, state planes, so on and so forth. And then you get into, sort of more of the, what we really mean by survey survey and project controls, which are the kind of monuments of usually metal, brass, etc. You After this lecture, you'll actually start walking around cities, and you'll be able to spot them because they are all over the place. So these are permanently installed brass or steel markers, right, with a stamped ID and benchmark information. And these are set up with, that total station, the GNS systems that I was mentioning before. Um, it is people, when I go to a new city, people are either fascinated or annoyed with me because I always go around and I'm always like pointing out all of this kind of all of this kind of stuff that is seemingly invisible until you know about it. But the important thing to know here is, what's the difference between like a laser scanning professional or reality capture and surveyors, right? So here at Integrated Projects, we do reality capture. We specialize in that, but we actually don't provide surveying for a variety of reasons. We have preferred partners that will do surveying and we'll set it up. But it's important to know, right, that they're actually two very discrete different positions and two different legally speaking different things, right? So laser scanning professionals, they can place targets, always a good idea to place them in high visibility, well distributed spots that they can use if other trade contractors want to use that as a benchmark. They can, but the laser scanning professional is not going to be holding a liability for that benchmark, right? As opposed to a surveyor who has a total station or GNS receiver, they're licensed, and they're setting up established coordinate system datums and instruments of calibration that legally are tying back to the UTM, the state plane, the project specific grids, etc. Right? But the laser scanning professional can use any of those control points, so they can effectively tie in their point clouds, right, with the survey benchmark data. And also, the laser scanning professional should understand when survey controls are needed, how to spot them, how to make certain judgment calls around, their verification, et cetera, et cetera. So, a little bit about LiDAR. Um, hmm, George, it's looking like my videos are not playing here, actually.
Yeah, I think you might want to just share your screen for these couple slides.
Yeah, let me do that.
While
Sorry,
you get
folks.
set up,
One
we'll
sec
we'll
here.
we'll, we'll come back. Yeah, cool. I'm
Just pull
gonna
this up.
add it to the scene. There you go.
Awesome. Okay. Cool. Sorry about that, guys. Yeah. So generally speaking, when we're talking about LiDAR, there's a whole bunch of different technologies, a whole bunch of different workflows, but by and large, today we're really talking about two different kind of technologies that you should have some kind of familiarity around. The first of which is the more traditional terrestrial scanning. This is where you set up a tripod and you spin around and you capture from one localized point millions of points around whatever the description of the reality is, whatever the capture is. And what you have to do is you have to set up, breakdown, set up, breakdown, set up, breakdown a number of different times. And typically, like the way that surveyors, or rather laser scanning professionals, will cost this out or schedule out a Gantt chart is, how many setups and breakdowns do I need to do? Um, the same could be said, right, for like drone scanning as well. But there's a new kid on the block, right, which is still lidar, but it's lidar which is moving through space, and that's known as SLAM. Um, for those that want to impress people at a dinner party, it's the simultaneous localization mapping lidar, right? So let's say 2.5 million points, lasers are shot out every second and captured back into the device, and the device is moving. So this is the animation here on the right, and the device is moving, and so we see this in pop up kind of everywhere, and it's becoming more and more prevalent. To the point that we're doing it now, right, on like construction grade 5 to 15 millimeter accuracy of all these points. But you see it pop up in self-driving cars, autonomous robots in manufacturing facilities. I have a Roomba. It has a lidar. So effectively, it's not a stationary position where it's shooting out the points. It actually takes into consideration the velocity that you're moving, or the speed and the trajectory that you're moving, to be able to recognize all of these kind of features for reality capture. So that all sounds probably a little intense, right? But just to sort of demystify it, what does this look like? In this case, this is a very new device, super cool device, from one of our favorite vendors, Navis. This is the MLX. And what he's doing here is actually, scanning with that LiDAR, walking around the space, registering it and putting it to a control point, which automatically puts those geolocated coordinates into all the rest of this crazy math that's going on. And then you can see here is basically doing like some of the post processing of that information, and effectively stitching together all of these different point clouds, as well as the virtual tours, so that we can in the matter of a day or two, we have a visual description of that space that we can walk around, and kind of see virtually. And to just get into it a little bit, I mentioned those two like really large issues, right? Is like the point cloud misalignment and the drift. The point cloud alignment, that happens. That could be a potential issue for either slam based or terrestrial laser scanning. So in the case of terrestrial laser scanning, every single time that you do a setup, you have to somehow get both of those that collection of millions of points together, and fuse them together so that they are all referenced to themselves locally in their space. Or in the case that you do it with control points, you can actually greatly help that whole situation by having those geolocated controls. A lot of other potential issues can happen here, and typically it's like the larger or more complicated the project is, the greater the concern for some of these potential issues. But the second one that I mentioned before was drift, right? And that's really for that's something that's cropping up because of this um, slam based technology. But by using targets or controls, it greatly increases the accuracy of all of these issues. There's a whole host of other QAQC checklists, right, that we go through. Noise, ghost points, overlapping points, low point density, all different kinds of things. But really, at the end of the day, the biggest the one single shot solution that we see to reducing a lot of these issues is setting up a target or a control point. So George, I've been talking for a while, but in terms of our customers, when should you actually bring this up, and what's even the whole point?
Yeah, I think it's important to I mean, we've talked about there's a recurring theme in a lot of our conversations about the importance of setting expectations. We've shown we've talked about what we call the regrettable conditions loop in the past, whereby you think you don't really need a kind of existing condition survey done with high accuracy, and then you realize you do, and then everyone that's part of that process, all the stakeholders involved, are kind of left struggling with like, why didn't we know about this sooner? And so I think it's important for and we want to work with everyone that's if you're watching this, we want to work with you and kind of figure out the ways in which we can provide better educational material such that clients that may not, it's very reasonable for them not to be in the weeds about these things, and not maybe know sort of the relative importance of one thing over another. But I think in general, it's really important to be seen as a strategic advisor as opposed to maybe a vendor. And we talk about this in the context of people that are providing services like us, that we work with, collaborate with, or even compete with. I mean, I think the important part here is that there is a gap that exists on the education side in general, and everyone is well serviced by helping to educate clients better on on these outcomes, because otherwise they just won't know, and then it'll be hard to advocate for it if we don't do that, right? And when or we advocate for it almost when it's too late. And so yeah, I think everything that you showed, I mean, even that like last animation where it shows the sort of this the discrepancy between two scans and how they have to be kind of aligned, and that was somewhat of an extreme example. But I think if you I mean, it's almost like there's a culture now of scanning that's emerging. So it might be like 5 to 10 years from now, people kind of understanding when they've played around with scanning equipment on their iPhones now allow you to sort of scan, but a lot of the tooling, a lot of the apps that are available like that kind of fall apart in different lighting conditions, or they fall apart across different floors, or et cetera. So that they'll intuit maybe some of those challenges. But in the meantime, on these kind of large professional ones, it's just so critical that we're the ones like establishing those expectations. And I think yeah, it's just super super critical. Oh, I think you muted.
Yeah, thanks. Yeah, so we're gonna kind of wrap this whole thing up, and as always, right, on all of our webinars we have freebies for you guys. So we'll get into that in just a minute. And a lot of these last slides, honestly, that we're gonna kind of go over are things that we're taking from our kind of giveaway this week. So the bottom line is, when do you use control points? Um, you got to ask yourself basically three different questions when you're evaluating a scan to bin project and whether to use control points or not. Yeah, in fact, whether you do scan to bin or not, you should. These three questions need to exist for establishing control points, right? They're not exactly dependent upon each other. You can have control points without doing laser scanning, right? In fact, if you answer yes to any of these questions, you probably should. The first one is it a large or complicated environment? I would also add, is it a featureless environment, right? So if you have a huge Walmart parking lot and you don't set up control points and you try to use SLAM based LiDAR, because it is so featureless, you can't position yourself in space. And so by definition, the the kind of algorithms are going to not be able to align all of the millions of points registering, right? So you're going to have scan drift. But we see the same thing with large or complicated projects. So anything over 25,000 square feet, honestly, anything that is like multi-level, 3, 4, 5 floors, those are reasons to really consider whether you should bring on a surveyor for control points. At bare minimum, you should set up at least target points, right? And target points again are when you're setting up these markers that you can tie into that aren't necessarily referenced to a geostate plane, but even those, just in terms of aligning the point cloud or rectifying a scan drift, can help considerably. The other one is anything that you do with high precision accuracy, right? So here at Integrated Projects, we're pretty firm on providing construction grade as builds of 5 to 15 millimeters. If you're doing anything like that, um, should consider whether you're going to use target or control points. And then the other one is, if the client is requesting or providing, or if there's any use for this thing to actually know where it is in space, where it's located in the world, you should probably use control points. So in Revit, for instance, if you want to align your project to get accurate daylight studies or solar heating analysis of your building, for example, you could reasonably guess, right? But if you have those basically those three different coordinates, the north, the east, and the height, from a survey, then you can actually geolocate it. Um, and if there's any other downstream, right? For any reason, if it's tied into a GIS system, if it has asset management, anything like that. Those are the three basic criteria that you should ask yourself. So we put together like this kind of control decision tree, which is just basically walking through. Will someone ever need to measure this to be able to scan to build off of? Would a drift actually matter? Maybe you're just doing facilities management and you don't actually need the 5 centimeter accuracy, right? Because you're not actually building from it. Maybe you don't need control points. Maybe you just need the asset, kind of information or containers for that kind of metadata. And so there's a lot of different benefits and trade-offs whether you use control points or not. It is true, control points add at least an extra day to the project. They will add additional cost, but there's, as we mentioned, I think in maybe 2 webinars ago, all of this really is an insurance premium, right? To start the project off in the best way possible to avoid failure downstream. And the longer downstream that your project goes without, setting it up properly, the potentially more risky and costly it might be. But you can also skip controls, right? If you want to mobilize quickly, if you want to lower the cost, and if it's sufficient for the deliverables. Here again is really just simple, and all of this is in the actual handout that we're going to give to you, and we'll show it to you in just a minute. But is it going to be tied into real world coordinates? Then yes, use survey controls. Is it useful for post processing? Absolutely, 100%. But even unmeasured targets, right? Super useful for that. If you don't have a surveyor, you can't have the actual geolocated survey controls, but you can ask for targets, and honestly, they should be recommending that they use targets if the project requires it. Do you need the relation, the vertical relationship of your multi-story building? Are those levels and datums like crucial? Should probably use control points. The more number of you might be able to get away with 2 or 3 floors, right? But the more floors that you have, as you go up and you're kind of trying to connect all of these together, whether this is SLAM or terrestrial, the higher likelihood that you're going to run into some accuracy problems. Um, so yeah, and talking a little bit about the cost benefit of this. Generally speaking, in my experience, right, and you'll have to get quotes for this and all of this. We actually at Integrated Projects make this super easy because in our kind of quoting tool, we actually have a button that is automatically checked if our kind of internal algorithm determines that this project probably should use controls, and that factors into our cost, right? But even if you're not using us, if you're working with another laser scanning professional or a surveyor, they'll be able to provide you with the kind of cost of this thing. Generally speaking, I would say it's going to be $500 to $1,000 per control point that needs to be set, um, and and they should also be able to look at your project and recommend whether you should use control points or not. And it will impact the speed. Typically the surveyor has to come out a day before the laser scanning professional does, but the benefits of getting correct and accurate data is tremendous. And so again, just going back to the two most common issues that you're going to run into with LiDAR scanning, it's these misalignments. In this case, this could be with terrestrial scanning or SLAM-based scanning. SLAM, obviously you can capture a much larger area because in one scan, because you can walk the entire floor plate, let's say, but you can only scan so much data. Typically every 20 minutes of data capture, you have to reset the scan, and then you still have to calibrate those together to align them. But even non-georeferenced targets can help significantly in aligning these scans. And then the second one is this kind of scan drift. And I'm not going to get into the technicalities of this and why it happens, but I hope by now this is sort of demystified, right? That in terms of SLAM, as we're shooting out millions of points and we're moving in space and calibrating all of those back, there can be scalar, nonlinear distortions, rotations, transformations of all kinds that can happen. And in this case, non-geolocated control targets will help for sure. The larger the project is, the more recommendation it would be to actually tie that in, geolocated with control points. So, a couple myths and a couple truths that we hear in the industry that, if you set up targets, that those are control points, or that control points are, primary survey points. Those are all actually three different things with sort of, as we've kind of gone over, three different levels of kind of severity or complexity, or not complexity, but kind of legality, let's say. And the other one is, just because you have more points or more targets or more LiDAR capture doesn't actually mean that it's going to be more accurate. In some cases, over scanning, it actually produces more of a problem, right? Because you have sort of self-conflicting points that are exactly overlapping inside of space, and like that can produce its own issues. But the same is true for control points. You don't have to put control points every 5 feet, right? You only have to put control points on major vertical elevation changes that you're having, right? So we typically when you come out of a stairwell, we'll typically put 3 control points right there to orient the 3 Euclidean axes. And George, do you have this this up that you can share?
Yep.
Okay,
Yeah.
perfect.
So just want to give a huge shout out to Suli on our team. head of operations. She did an amazing job putting this together. Just want to give her flowers. But yeah, so essentially, this is I just shared the link for everyone. I believe it's mostly available on LinkedIn, but there's a link there so you can actually access this for free and download it. Um, it's a primer. It kind of goes over a lot of what we went through in the conversation today. Um, but yeah, I just want to give you a little bit of a taste as to like what it looks like, and really well put together, and I think covers a lot of ground. And so yeah, it includes some kind of the um, kind of the decision tree that Tyler went over a little bit just a second ago. And yeah, I think it's going to be really helpful for everyone that's joined us today, and hopefully you share it around with folks that you think could benefit from it. Again, it's a free resource. No need to give us an email or anything. We'll probably hear from you at some point. So it's all good. But yeah, so yeah, if there's anything else that when you see things like this, if there's anything else that you think that we should cover, we're very excited to. Um, and I think with that, we can maybe just talk a little bit more about any questions that people might have. But let's just jump back to the presentation. One second. Let me just stop screen sharing. And
Yeah, so if anybody has any questions, feel free to drop them in, related to control points or not. Maybe you want to have some questions about Vegas for George.
yeah, oh, sorry. Got some old slides in here. Yeah, while we wait for some questions as they come in, yeah, I think maybe we can kind of talk a little bit about I don't know. I mean, I think as we were preparing for this presentation, it's what we talked about was like very technical stuff around it, but it is very fascinating. Even just thinking about like the history of these things. Like these things don't just come out of nowhere, right? It's like why would we go through the trouble of putting all these metal markers in every city and not just in the US but in the world, right? These are everywhere. Why should they exist, right? And it was very interesting going back and even learning that it was a big push early on by even Thomas Jefferson looking at how to survey the coastline. Was a big maybe not for metal markers, but the evolution of it being something that was all about understanding the coast to start, and then kind of moving inward from that, and the coast being like really important for everything from trade to from the military perspective, right? It was like the biggest surface area that the United States had. And yeah, it's incredibly fascinating to know how much it's tied to, or this history of these points in general are tied to our relationship with land or our relationship with property. One of the things that Tyler and I were talking about was a conversation we had with someone at Autodesk University that was like really tuned in, like 20 years in the industry on this topic or more, and was talking a lot about the present day challenges of recognizing that the world is moving. So, sort of like, okay, we've put all these markers on the ground, but what happens when there's an earthquake and things shift? And it happened in Japan, and it was such a big issue in Japan that they volunteers went out to help the country take stock of actually where were these buildings now, because they weren't where they were before. And that was back in like 2011. And so it's almost like these things aren't they operate at different scales, right? We're talking about the scale of probably much smaller, right, within a single building, maybe a couple buildings, but how it ties into this bigger system that's not just even national but global, to the point where like it's just fascinating. So it's like how it's being used, how we're rethinking the use of these um, uh, these planes and these different coordinate systems when it comes to GPS, because you can now imagine right now things that are happening in war, right? Where new tools are coming out that cannot rely. You have to operate in conditions in which you just cannot depend on GPS because now there's this feedback loop between the tools that we build, right, and somewhat how something as like as simple as a marker on your street at the end of your street actually ties to drone warfare is it's one of those things again where it's like very fascinating, and we get to approach it from just one scale, but it's just
Yeah.
incredible to know how this has implications globally.
Yeah, absolutely. I mean, that kind of reminds me of a book that I read from Manuel de Landa, and he kind of goes into the whole kind of the science and study of geology and rock formation and metamorphic rock and all of this stuff, and it's like at a certain scale of time, that rock, right, actually obeys the laws of like fluid dynamics, right? Because it's like, yeah, this it's fascinating subject,
A
100%.
thousand years of nonlinear history for the folks that are trying.
Yes.
That's the book title.
Yeah.
Yeah, no, that was also very formative for me. It probably is the book that I can go back to and say my worldview is pretty much predicated on that book. But yeah, it is fascinating, this whole conversation of how do you even track accuracy in general, and so it's exciting for us to like keep diving into this world and understand its implications. And I think for those that want to jam out with us and nerd out with us, we're available. Hopefully, we're talking more. I mean, we can kind of what is it? Flow in between conversations like this and more maybe practical things you have in your work week where you want to get a project done. But yeah, I think we can kind of wrap it up there. I'm really excited to share this with everyone. Shared the link. Feel free to reach out to us. Email us, georgeintegratedprojects.co, Tyler at integratedprojects.co. Happy to share the link with you there as well. And if you ever have a project in mind where you feel like it could benefit from, our feedback, no project is too early enough really for us to have a conversation. The earlier the better in many ways, because it's at those early stages when things are coming together that have probably the most consequence for project outcomes. So, yeah, excited to see you wherever we see you, and thanks for joining us.
And also, the next webinar
Yes, we
is
should totally.
yeah.
My bad. Kind of skip through some of these slides here real quick. Boom. It's going to be Jose, co-founder or founder, sorry, of Integrated Projects, educating us on how to educate clients on the benefits of scan to BIM. So, really excited to have him back on here to talk to you about his experiences doing this. And so I think it's going to be really valuable for those in and around the industry that have to do the same.
Absolutely. So that should be coming up in 2 weeks on April the 5th.
Yep. Cool. All right. Thanks, everyone. See you
Perfect.
around. Follow us on
Thanks.
LinkedIn for more updates. A lot of cool stuff coming up. Cheers.
Cheers.